Hello, my name is Blanche. I'm the inventor of the SafeSight product line, including the roadside onboard unit, shown here and commonly referred to simply as the ROBU. Let me explain how the ROBU device works to assist wheelchair pedestrians to navigate traffic intersections safely. TLM's aim here is to show how the ROBU will reduce the risk of traffic-related accidents imposed on wheelchair pedestrians. We all know that while accidents can happen, I will explain how accidents with vehicles can be avoided with the wheelchair pedestrians' use of SafeSight's ROBU device. Here are the main features of the ROBU device that makes wheelchair pedestrians navigating traffic more safe. First is the speaker. This speaker gives an audible message to the wheelchair pedestrians to proceed when vehicle traffic has been notified of their presence. Secondly, an amber light serves as an acknowledgement of successful communications with all 5G parties. Thirdly, there is a USB port for remote storage of wheelchair pedestrian subscriber data and auxiliary device power sources. Fourthly, a graphene, lithium, solar cell battery is resident on the ROBU. For an always-on, always accessible for 5G communications. Because of this feature, there is no power on or power off switch. Fifthly, the ROBU has a reset button to capture updates to software and DMV safety messages. And lastly, the ROBU antenna is only used in locations where 5G communications tower is remotely located from DMV cloud server processing. In order for the ROBU device to operate, it requires the support of the following agencies, namely, the FCC, the cellular companies, the DOT, the NHTSA, and the DMV. Now let me explain the roles these agencies play in providing safety warnings for wheelchair pedestrians in traffic. The FCC, better known as the Federal Communications Commission, will allocate a free communications channel for public safety use from the new 5G spectrum, which will include the channel used by the ROBU device to assist wheelchair pedestrians to travel in traffic more safely. The typical cellular companies will connect DMV-approved ROBU devices with registered wheelchair pedestrians users. The DOT, commonly referred to as the Department of Transportation, will ensure that 5G high-frequency microwave antennas are effectively stationed within and around street intersection. The NHTSA, also known as the National Highway Traffic Safety Association, will create and issue updated basic safety messages for all vehicles equipped with DSRC capability and wheelchairs equipped with ROBU capability to respond to each other effectively. The DMV, or the Department of Motor Vehicles, will distribute and control these basic safety messages between DSRC vehicles and the ROBU devices of wheelchair pedestrians to ensure commuter safety through identification and communication. The wheelchair's ROBU device can only function within a robust 5G cellular environment shown here. The centerpiece of such 5G cellular environment consists of the MIMO tower. The MIMO tower communicates with the DMV cloud servers that control safety messages. These safety messages are uplinked and downlinked from the DMV cloud processing servers. When these safety messages are received and processed by the DMV servers, the cloud sends commands to the MIMO tower to broadcast acknowledgement signals and safety messages to the area 5G parties, including the wheelchair's pedestrian's ROBU device and the automobile's DSRC device. Within the non-5G cellular environment, a wheelchair pedestrian approaching a traffic intersection, even with a traffic control light, the wheelchair pedestrian is exposed to the risk of an accident because of not being seen by a distracted motorist in traffic. However, within the 5G cellular environment, where the automobile's DSRC device is communicating with the wheelchair pedestrian's ROBU through the MIMO tower and the cloud's DMV servers, a distracted motorist can electronically detect and be aware of a wheelchair pedestrian in the immediate area, thereby reducing accident risks and increasing safety to all commuters using the intersection. The wheelchair pedestrian equipped with a ROBU device, entering an area radius of 120 yards from a MIMO tower and cloud servers to warn motorists. The technical information messages are uploaded to the DMV cloud servers that distributes broadcast notifications to local area vehicles equipped with DSRC capability, thereby notifying area vehicles that a wheelchair pedestrian is present and while the wheelchair pedestrian may not be seen by the motorist, the wheelchair pedestrians are electronically seen by vehicles equipped with DSRC devices, which indicates to motorists to proceed through the intersection with caution. In this instance, the wheelchair's ROBU, communicating with the vehicle's DSRC, reduces the risk of an accident and thereby increases intersection safety. The following diagram illustrates how the automobile's DSRC device responds to the ROBU's technical information messages to notify motorists that a wheelchair pedestrian is in the area of the intersection. In this instance, a lamp on the dashboard's instrument panel will light. This lighted lamp will signal to the motorist, even though unseen, that a wheelchair pedestrian is in the intersection. With this ROBU signal received by the vehicle's DSRC device, the motorist should then look out for the wheelchair pedestrian, and to proceed through the intersection with caution. Now let's consider how the wheelchair's attached ROBU device responds to the vehicle's DSRC device. A vehicle's DSRC uplinks a basic safety message to the MIMO tower, and ultimately to the DMV cloud server. After cloud processing of the BSM signal, the DMV cloud servers broadcast the basic safety messages to area ROBU devices attached to the wheelchair with recommended Velcro tape. The wheelchair pedestrian's ROBU device responds to the broadcast acknowledgement message sent from the vehicle's DSRC device indicated by the illumination of the amber light. The amber light on the ROBU is illuminated when the DMV cloud servers are communicating with area vehicles equipped with DSRC technology and consequently responds to the ROBU with an audible message to proceed with caution through the traffic-laden intersection. In the event of a wheelchair traffic accident, the wheelchair's ROBU device responds automatically by going into an emergency state. Because the ROBU contains an accident algorithm protocol, an emergency state is not entered by a simple bump or even a fall. This emergency state software uplinks a distress signal to the local MIMO tower to subscriber files located on the DMV server shown here, or also from subscriber data located in memory on the wheelchair pedestrian's ROBU device. The cloud DMV server selects two categories of subscribers assigned by the wheelchair pedestrian. The first notified are the wheelchair pedestrian's healthcare providers. The second category notified consists of the wheelchair pedestrian's family. This emergency state notifications are issued automatically in the event of a wheelchair pedestrian's accident. Well, there you have it. At this time, on behalf of the TLM Corporation, I would like to thank you for your interest in our unique ROBU device. Again, our ROBU device will provide a more safe passageway for all wheelchair pedestrians navigating traffic.